Okay, hello everybody, and welcome to today's class. Today's topic will be about systems of algebraic equations. Okay, so a lot of you have been to my last class, so this will be a continuation of last class. Okay, so can everybody see the screen all right? Yes or no? Okay, can you see now? Okay. Okay, I'm sharing my screen, should be all right. Okay, so this is our schedule. So first we're going to do a review on our three types of methods to solve systems, like elimination, substitution, and graphing. Okay, and then we're going to go deeper into elimination and substitution because those are the main two methods that you use for systems. And then we're going to be modeling real life problems with systems. So very useful. The last subject. Okay, so let's first review. Okay, little review. So what is the solution to a system of algebraic equations with two variables? Okay, and that will be the intersection of the two lines on the coordinate plane. So today we're only doing algebraic equations with two variables. Okay, so only two lines. Three lines, a bit more complicated. You have to get used to systems first. So let's say we have, okay, where did my presentation go? Okay, let me reopen. Technical issues. Let's see. Should be in here. Okay, sorry for the thing. Okay, where did it go? So please wait for a moment. I'm trying to find my presentation. Just disappeared. Okay, technical issues. It seemed to be in here. Okay, there we go. So I found it now. Okay. So can you all see my screen now? Yes or no? Okay, sorry for the technical issues. Okay, yeah. So as I was saying, the solution to a system is the intersection of the two lines on a coordinate plane. Okay. So let's see our systems. Okay, let's random system of equations 2x plus y equals 30, and then 3x minus y equals 20. Okay, so many of you know that these two equations are in standard form, and then you can graph standard form, right? So maybe like this isn't exact. Maybe those two lines. So this is our coordinate plane. Maybe those two lines might be like this. And then this would be the intersection point. Okay, so I want you to visualize the intersection point. Okay. And let's review our systems with how to solve with graphing. Okay. So let's solve this with graphing. So 2x plus 3y equals 6, and y equals 4/5 x plus 2. Okay, so please solve this system with graphing, okay? I'll give you a few moments. This shouldn't be too hard for the people who have been to my last class. For those who don't know how to do it, just hang in there. I'll walk you through it later. Okay. Give you a few moments. I'll put the slide up here. Okay, give you a few moments, put it in the chat box. So any answers yet? Okay, I'll walk you through it then. So, systems with graphing. Okay, so we know that slope-intercept form is the best way to graph because it gives you the y-intercept and the slope. Okay, so very easy to graph. So let's convert this to slope-intercept form. Okay, let's convert. So first step would be 3y equals negative 2x plus 6, right? Okay, and then next we have y equals negative 2 over 3x plus 2. Okay, so there we go. And then we have y equals 4/5 x plus 2. So let's graph this one. So let's graph the first equation. Okay, so 2 will be the y-intercept. So 1, 2, something like that. And then our slope. So negative 2 over 3 can be also 2 over negative 3. So remember, it's vertical change over horizontal change. So first, negative 2 is going to be the y. So go down by 2 and then go to the right by 3. 1, 2, 3. There we go. That's our point. And then we have positive 2 and negative 3. So go up by 2, left 2 by 3. Okay, 1, 2, 3. There we go. Something like that, and it forms a straight line, right? Okay, and then we have our second one. So we have another y-intercept of 2, and this is going to be the y-intercept. Okay, and we don't even have to look at the other line because our y-intercept is our intersection. Okay, so next, let's review substitution. Okay, so solve this system with substitution. Okay, so please solve this system. Okay, I'll give you a few moments. Put the answer in the chat. Okay. Jason and Sophia don't get it. And also Rita. Okay, I'll explain it again. So graphing, these two lines form two, these two equations form two lines, right? And the intersection of them will be the answer. Okay? And the coordinates of this particular intersection will be the answer. So let me graph the other line real quick. 1, 2, 3, 4. Then there we go. Right here. That should be our line. About like that. Okay, my lines aren't that good, but you get it. The intersection is the answer. So what is the intersection? Okay, it is 0, 2, right? So that is the intersection because the intersection is this point right here, and that will be 0, 2. So you can say that x equals 0 and y equals 2. Okay? So graphing, you don't actually use graphing when you're solving. Okay? So don't use graphing when you're solving because it's very troublesome. What if your point is a fraction? Okay? Very hard to see. So graphing, I wanted to teach you graphing because I want you to visualize the intersection. Okay? So don't actually use graphing when you're solving it. Now I'm going to teach you substitution, which is extremely useful, and also elimination. Okay. So please try and solve this system with substitution, and then I'll explain how it works later. Okay. There. So, I'll explain substitution then. So we already have y solved for us, right? Y equals 3x minus 6. So y equals 3x minus 6 and 3x minus 6 equals y. So we can substitute them, okay? So we can substitute 3x minus 6 for y, okay? So 2x plus y equals 30, right? That's our current equation. What if we substituted 3x minus 6 in for y? Okay? Then we only have one variable in the equation. And with one variable, you can actually solve the equation, right? So 5x equals 36, x equals 36 over 5, right? So for those not familiar with linear equations, so what I did was combine like terms, 2x and 3x, move the negative 6 to the other side using inverse operations, and then finally I get 5x equals 36, and then divide by 5 both sides to keep the equality, and then you get 36 divided by 5. So now I'm going to explain elimination. Okay, elimination. So this one, a lot of students have trouble with because they don't understand why it works. Okay. So elimination is basically adding or subtracting the equations. Okay, so we're adding and subtracting the equations. So this would be equation 1, equation 2, right? So we add and subtract these two equations so we can eliminate one variable. So basically you add everything on the left side and add everything on the right side. So let's add equation 1 and equation 2. Okay, so 2x plus 5x, right? 7x. Negative 3y plus positive 3y. That'd be 0, right? Okay, canceled out. And then 20 plus 15 equals 35. X equals 5. Okay, x equals 5. Okay, and then after you find x, it'll be easy because once you know x, you can just substitute 5 for x, right? So I didn't bother solving for the showing you how to solve for y in substitution because I know that you know how to plug it in. Okay, so once you find x, you can just plug it in. Plug in 36 over 5 for x, and then you can find y, right? Okay, very easy. So after we added these equations, right, y was eliminated because it was negative 3y plus 3y. Of course, that would be canceled out, right? So you have to spot these, and then you can figure out what to do. So in this system, elimination is the most effective method, right? much more faster than substitution or graphing, okay? So you have to see these things, and you have to figure out which method is the best for solving a system like this. So I'll plug in x into one equation. You don't have to do two. The result will be the same, okay? So plug in x as 5, so 2 times 5 minus 3y equals 20, okay? 10 minus 3y equals 20, okay? And then negative 3y equals 10, okay? Y equals negative 10 over 3. There we go. We can write it in the ordered pair, 5, negative 10, 3. So keep in mind that this is actually the coordinates of an intersection. Okay, so you can't write it like x equals 5 or y equals negative 10 over 3, okay? This way is much more better because you know that this is an intersection on a coordinate plane. So it's better to write it in an ordered pair. Okay. So still confusing. I'll explain elimination again. Okay? So, actually, I'll explain it on the next slide because next slide will be making sense of elimination. Okay? So I'll explain why you add and subtract equations and why it makes sense. So, let's say x equals 4 and y equals 2, okay? X equals 4 and y equals 2. Then does x plus y equals 6? That is true, right? If x equals 4 and y equals 2, then we can just plug in the numbers and we can get 6, right? Okay? So, what are we actually doing here? Okay, you can think of it like plugging in the numbers, okay? We already know what x is, we already know what y is. We just plug in the numbers, right? And then we get 6. But there's also another way to think of it, and this involves elimination. If you just add the left side and add the right side, what do we get? You can't add x and y, they're different terms, okay, undefined. So you can separate them, x plus y equals, what is the other side? 4 plus 2, right? And what is that? That is 6. And here we get x plus y equals 6 again. So with that, I can prove that you can actually add and subtract equations. And we can use this to our benefit to eliminate some variables, okay? Okay, Jason, which part do you not understand? Okay, which part do you not understand, Jason? And Sophia? Okay, the elimination. I just explained it, but I'll explain it again. So the elimination, you want to make sense of how we actually eliminate the variables. Okay, so negative 1 plus 1. Can anybody tell me what's that? Okay. Equals 0, right? Negative 1 plus 1 equals 0. So we can make sense that negative x plus x equals 0 as well. Well, if we add negative x plus x, we just cancel it out, right? We cancel x out. Okay, it's 0, it's done. So that's the basic idea we want in elimination. So, very simple one I give you. Okay, so x minus y, x plus y equals 1 equals 1. Okay. Remember, we can add equations. So let's add this equation. Okay, we want x plus x, negative y plus y, and then 1 plus 1. we go, 2x plus negative y plus y. What is that? Negative y plus y, we get 0, right? So you just basically canceled out y. Okay, plus 0 equals 2. Now, from now on, okay, you can solve the equation, right? So we get 2x equals 2. Now we want x by itself, right? And how do we get x by itself? We divide by 2, right? Because x is multiplied by 2. We have to divide by 2 to get x by itself. But to keep it equal, because this is an equation, both sides have to divide by 2. X equals 1. Okay. Okay. Confused with the negative. Okay, negatives. Okay, Sophia, you might not understand the linear equation part. You might want to check my videos on 5th and 6th grade algebra. Okay, get a better understanding of negative. Okay. So I'll basically just explain negatives right here. Okay. So you understand what a negative is, right? It's something below 0. Okay, so negative 1 would be 0 minus 1. Okay. And then positive 1. So, I don't know how to explain negatives. Very simply, let's have a number line, I guess. This is 0. This is negative 1. This is 1. Okay, so this distance right here, let's just say that's 1. Okay, so if you have negative 1 and then you add 1, if you add 1, that's just adding this distance. Now what does that do? It fills that negative up to 0 again, right? So I guess that's my most simple way of talking about negatives. So maybe once you'll use it more, maybe you'll understand it more. So please use elimination or substitution to solve this system. Okay, use elimination or substitution. Okay, and I'll walk you through this first one. Now we have x already solved for us, right? We have x already solved for us. So if we already have x solved for us, then it's best to use substitution, right? Because we can substitute 1/2 y plus 3 in for x. Okay, they're equal. And then you'll have an equation with only y, and then you can solve it, right? So any questions so far? Okay. Okay, very good, Reza. Negative number is a real number that is less than 0. Okay, yes, negative numbers represent opposites. So if you add opposites, right, they cancel, right? When you add opposites, they will cancel. Okay. Alice. Okay. When will I teach you sequences in series? Okay. Sequences in series. We're currently doing it in algebraic session, I guess. Algebra unit right now, so maybe later. Okay, maybe later. Back to the topic. 7x plus 2y, right? We can substitute in 1/2 y plus 3 for our x and then plus 2y equals 40. There you go. And then we only have an equation with only one variable. So 7 over 2y plus 21, because this is distributive property. Multiply all the numerals, all the objects in the parentheses by 7. Okay, and once we simplify, we get this. Okay, and then plus another 2y. Okay, equals 40. So the big idea, and I taught this. Okay, I taught this in Algebraic Equations 1, which was my second class. Okay, very far back. Okay, you have to isolate the variables, right? We want to find y. To find y, that equals some number. Okay, so you isolate all the numerals on the right hand side, and all the y's, I guess, on the left hand side. Okay, and then we can just combine the y's. Let's say you get 3y equals 3. We don't want 3y, right? We want to find y. Okay, so you divide by 3 both sides. Y equals 1. Okay, so that is very basic principle of algebra. Now, how do you isolate 21 and 2y and 7 over 2y? Because there's a 21 right here. 21. Okay. Okay. So we want to move it to the 40 right here, right? And when we move it, we have to use the opposite sign. Okay, we have to use the opposite sign. It's called inverse operations. Okay, so 7 over 2y plus 2y equals 19. Okay, because we subtracted 21, not add. Now, why do we need to subtract? Okay, why do we need to subtract? So let's say you have y plus 21 right here, and we have a 30. Okay, this is completely random, not related to the problem. It's just explaining the principle. So if you want to cancel out 21 from this side and isolate it from y, you have to subtract 21, right? Then you get 0. Okay, so this is where negative numbers come in place. But this is an algebraic equation. This is an equal sign. You want to keep it equal, right? So this side also has to subtract 21. That's why, on easier terms, you just move it to the other side and change the sign. Okay. And now, this equation. So 7 over 2y plus 4 over 2y. Okay, common denominator, and then equals 19. Okay, 11 over 2y equals 19. Okay, so that is our equation. Now, what do? Okay, you want to isolate y. Okay, so now how do you isolate y? Okay, so you have 11 over 2y, right? So you just multiply by 2 over 11. Okay, so if you multiply by 2 over 11, it'll be 22 over 22y, which is just y, right? Because it's just one y. Okay, so multiply by 2 over 11, we get y equals 19 times 2 over 11. 19 times 2 over 11 is y equals 38 over 11. Okay. Okay. No problem. I'll explain the the concepts if you don't understand. Okay. So now that we have y, okay, let's erase this. Now that we have y, we can find out x, right? We can find out x. Okay, so x equals 1/2 38 over 11, because that is what y is. Okay, we're substituting in y into this equation, plus 3. Okay, x equals 38 over 22. Okay, plus 3. So then we have x equals 19 over 11. Yes, 19 over 11. And then, okay, we plus 3, right? Okay, and we find the common denominator. 3 over 11, which is still 3. And then we get x equals 52 over 11. Okay, so very good. That should be our answer. So any questions? Okay, no questions. I'll continue. So now we have our next problem, okay? Use elimination or substitution to solve this problem. Okay, so this problem, I'll walk you through it, okay? Because this is one of the harder elimination problems. Now, let's try adding, okay? Let's try adding. So don't write anything on your papers yet. Let's try adding the equations. So 9x plus y, because 3y minus plus negative 2y equals just y, and then equals 35. Now what is this? We have another equation, right? Is this true? Yes, it is. But can we solve it? No, of course not. Because we still have two variables. We can't eliminate anything with this. So what do you have to do? What you have to do is you have to multiply both equations by some number. So let's multiply this equation by 2. Okay, by 2. And this equation by 3. Now, not only you can add and subtract equations, you can also multiply and divide equations. Okay? So, let's try multiplying them. 2 times 4x, 8x plus 6y equals 3, because you have to multiply every term. You can't just multiply one term. You have to multiply every term in the equation. Next equation, 3 times 5x, 15x minus 6y equals 60. Okay, 60. So now can you add it? Let's try adding. Try adding again the x's, y's, and the numerals. Okay, 8x plus 15x, what is that? That is 23x. And then 6x plus negative 6y plus negative 6y. That's a 0, right? We eliminated it. Okay, we eliminated it. And then that should be equal to 90. 23x equals 90. X equals 90 over 23. So how did we get to this step? So does anybody have any questions on how we got to this step? Okay. So how did we get 30? Okay, how did we get 30 and how did we get 60? So remember, we're multiplying the equations. Multiply every term by 2. So 4x by 2, 3y by 2, 15 by 2. That's how we get 30. Okay, next equation, multiply everything by 3. Okay, 5x by 3, negative 2y times 3, 20 times 3. That's how we get 60, right? Okay. So that's how we get 30 and 60. So remember, always remember you have to multiply every term, okay? Like the distribution method, okay? Distributive method, okay? Like this, just multiply every term in the parentheses by 2, okay? And then now we find x. We can plug that in for y, right? So let's see, 4 times 90 over 23 plus 3y. So this should be an x, right? Just plug that in because we already know what x is. We plug in 90 divided by 23 as x plus 3y equals 15. Now we can also do 8 times 90 over 23 plus 6y equals 30. Because this is the enlarged equation. This is the original equation. Okay? You can do either one. Okay? You can do either one. You can also do 5x minus 2y equals 20. Any equation that is true. Okay? So let's do the first original equation. 4 times 90 over 23 plus 3y equals 15. Okay? 360 over 23 plus 3y equals 15. Okay? So now we can solve it, right? Okay, we can solve. So 15 times 23, just make some quick calculations here. Okay. So let's see, let me get my calculator out. Okay, so 15 is equal to 345 divided by 23, okay? And then we just move it to here, okay? And we get 15 over 23. Okay, right. 15 over 23, and then we still have a y, so let's move it to the other side, negative 3y. Remember, change the signs. Turns into negative 3y, and you actually subtract 345 over 23. Okay, now we need y by itself. Divide by negative 3, divide by negative 3, and you get your answer. Okay, so this might be a pretty complicated fraction, but you get the idea. Okay, so this is how you solve elimination. With elimination, and sometimes you need to multiply it to fit your needs. Okay, so any questions? Oh, okay, Jason, very good question. Why do you multiply it by 2 and 3? So a lot of people get my meaning, like elimination. You eliminate one variable, but why do you need to multiply by 2 and 3? So let me explain. Look closely, and when you're solving systems, you have to observe very closely the equations. So what are you given with? Let's say you want to eliminate y. let's eliminate y. Okay, what is the least common multiple? Least common multiple of 3 and -2, okay? Because 3 and 2 are the coefficients of y, okay? Numerals before y, okay? And you know that the least common multiple of 3y and 2y is 6y. Now, how do you get to 6y? We can't just turn that to 6y. We have to multiply it. So 3y times 2 equals 6y. Okay? -2y times 3 equals -6y. Then that sets you up for elimination. Okay? That sets you up. Because if you just add them without thinking, then you're not going to eliminate a variable. Okay? So let's say you want to eliminate x. Okay? So what is the least common multiple of 4 and 5? Okay? The least common multiple of 4 and 5, I think would be 20, right? 20. Okay, yes, 20. 20x. Now you can multiply by 5 and multiply by 4 to get to 20x, right? But let's turn that into -4 because you want to add it, right? If you add 20x and 20x, you'll get 40x. You want to add 20x and -20x. Cancel it out. Okay. So does that explain it? Okay. Does everybody understand why you multiply? Okay, very good, Jason. Okay. Catching on very fast. Okay. Our next subject would be modeling with systems. Okay, so modeling, you want to represent the problem, okay? So let me walk you through the first one, and then the rest should be pretty easy to understand. Because systems, let's say you go into the real world, okay? Nobody's going to walk up to you and just give you a systems of equations problem to solve, okay? Sometimes you might be calculating speed or something, might calculating volume or something, okay, in your future jobs or something like that, okay? So you need to represent the problem. No one's going to give you the actual equations. No one has time for that. So I'm going to give you a problem. The difference of two numbers is 3, okay? The two numbers, okay, I gave you a hint right here. Let x be the smaller number, okay? So we have two variables, x, and then y. Y is going to be the larger number, okay? So since y is the larger number, y minus x equals 3, because we're given that the difference of those two numbers is 3, okay? So since y is the larger number, y comes first, and y minus x should be equal to 3 because that's the difference of the two numbers, okay? So the sum of the two numbers is 13. So y plus x equals 13. And write a system to represent the problem and solve it to find the two numbers. You already have it, right? While reading the problem, we already have two equations. So this is very convenient. Okay. So we just add this now. Look, we have a negative x and a positive x. Okay. Negative x and a positive x. We just add the equations. So 2y plus 0 equals 16. What is y? Y equals 8. Okay? And we can plug in that to any equation. So let's plug it into this original equation. Okay, this is equation 2. Let's plug in x. Let's plug in 8 for y. So 8 plus x equals 13. Move it to the other side. Subtract 8 from 13. X equals 5. That's very easy, right? Now, how do we check our answer? It gives you the conditions, right? It gives you it gives you the conditions. So the difference of the two numbers is 3. Does 8 minus 5 equal 3? Yes, check. The sum of the two numbers is 13. Does 8 plus 5 equals 13? Yes. Okay. Very good. Next problem. This one will be slightly harder, and then you guys can solve it. Okay. So please try to model this equation. It's fine if you don't know how to solve it, but at least try to model it. Okay. At least try to represent the problem. Okay. So please try to represent this problem in 2 equations. Okay. So any questions? Okay, Jocelyn says x equals 5 and y equals 8. Okay. So the purpose of using the let statement, the only reason I use that is that you use the correct variables, okay? So so we have the difference, right? You can't subtract a larger number from a smaller number, okay? That equal negative, okay? And that's not very convenient to let a negative into the problem. Good to only use positives, okay? Easier, okay? So that's why I told you that y should be the larger one and x be the smaller one. Okay, and this is the problem. I'll give you a few moments to put it in the chat box. Should be relatively easy. Okay, no answers yet. I'll give you a few more moments then. Okay. Okay. One message. Let's see what that is. Okay, Jason doesn't know. Does anybody else have an answer? None. Okay, I'll walk you through it. This might be a bit confusing. High school A. Okay, so this is high school A. Okay, high school A rented 8 vans and 8 buses with 240 students. So 8V plus 8B equals 240, right? So high school B rented 4 vans and 1 bus with 54 students. So 4V plus B equals 54. Okay? Now, how do we solve this then? Okay, how do we solve this? We can just add or subtract these equations. We can't use elimination right now because it won't eliminate anything. Okay, so as I explained to you, Jason, we have to multiply these equations by a certain number. Okay, so let's eliminate V. Let's eliminate V. Okay. So V, what is the least common multiple of 8 and 4? That would be 8, right? So you don't have to do anything to equation A. Let's multiply equation B by -2. Then you can add it, and then you can eliminate. Okay. So times -2. So negative 8v plus negative 2b equals negative 108. And then you just add the equations. So what is 8v plus negative 8v, that'd be equal to 0, plus 8b plus negative 2b equals 6b. That equals 240 plus negative 108. Okay, so that'd be 132. Okay, that should be correct. Let me check on my calculator. Okay, yes. And then to get b by itself, you just have to divide both sides by 6. b equals 132 divided by 6, which is 22. Okay, which is 22. So each bus can hold 22 students. Okay, so let's substitute that in. 4v, okay, substitute it into equation b. 4v plus b equals 54. That's our second equation. So now we know what b is. Let's substitute 22 in for b. So 4v, let's move 22 to the other side. 4v equals 32. Okay, b equals 8. Okay, so each van can hold 8 students, and this is pretty reasonable, right? This is pretty reasonable. Okay, so our last problem, and this one is a bit hard, so I will walk you through this one. For those who have an idea of how this works, please follow on your paper, okay? So, a boat traveled 336 miles downstream and 336 miles back, okay? The trip downstream took 12 hours, and the trip upstream took 14 hours, and that's kind of reasonable, right? Because once you go downstream, the current is pushing you there, so you go faster. Now, if you go upstream, the current is stopping you. Okay? Current is stopping you. So, wait, no. Okay. Wrong diagram. So, let's see. Yeah, right here. The current never changes, but you change. Okay, so this, let's say this dot is you. Okay. You're going downstream, the current is pushing you, okay? But if you're going upstream, okay, then wait. So in this diagram, you're going this way, okay? And you're trying to go up, go this way. Then you're into the current, right? So you go a bit slower. So 12 hours and 4 hours, very reasonable. Now write a system to represent the problem and find it and solve it to find the speed of the boat in still water and the speed of the current. In still water there's no current at all, just still water. So let x be the speed of the boat in still water. X. So this is the downstream equation, and the other equation will be the upstream equation. Okay. Downstream equation, x plus y equals what? Now, why do we need to plus add y? Okay. Why do we need to add y? Okay. We need to add y because once we're going downstream, the current is pushing us, okay? So it makes us go faster, okay? And y is the speed of the current, so you need to add y. Now, x plus y equals 12, right? That is incorrect. Now, x plus y equals 336, right? That is also incorrect. Now, let me ask you, what is speed? Speed is distance over time, right? So speed is distance over time. Now, we have the distance, right? 336 gives you the distance very clearly. And we have the time, right? 12 hours. So, this should be 336 divided by 12. And 336 divided by 12 is 28. Okay. It is 28. And the other equation, the current is going against you because you're going upstream, right? The current is going against you. So that's why we have to minus y from our equation because the current is stopping you from going that fast. That's why the upstream trip should take longer, and it indeed is. Okay, so 336 divided by 14. Okay, 336 divided by 14 should be 24. Okay, so this is going 28 miles per hour. Okay, 24 miles per hour. Okay, so the upstream one is a bit slower. Okay, and now we solve it. Okay, we can eliminate y, right? Straight off the back, we just add those equations. So 2x equals 52 because 28 plus 24. Okay, then x should be 26. And then we just put that in. Okay, so 26 plus y equals 28. We just plug that in into the first equation, which is the downstream equation. Then y equals 2, right? Y equals 2. The speed of the current is 2 miles per hour. Let's plug it into the other equation to see if that's correct. The other equation, 26. 26 minus y equals 24. So this is equation 2. Let's plug that in. Let's plug x in as 26 to check our answer. Okay? So 24 over here. Okay, 2 equals y. Okay, same thing. So we get our answer at x should be 26, 2. There we go. So that was our last problem. So thank you everybody for listening, and be sure to like the video, subscribe, and turn on notifications. Okay.